In this video, we're going to be talking about binomial expansion. So this is our first question, and there are two major methods in which we would solve binomial expansion, and they are the Pascal method and the Pascal triangle method, and then the combination method. So I will do both of them, and then you can choose whichever you prefer. So let's carry on. Okay, so we have, using binomial theorem, expand 1 plus 2x open into close bracket, everything raised to the power of 3. So for the Pascal's triangle, all right, it would always start with a 1 at the top. So let's have 1 here. So we can have a 1 here. It always starts like this. Then it always has a 1 at the side and at the end. Okay, so it goes like this. As we start to write more rows, then you would see that it forms like a triangle. Alright, now remember I said it has a 1 at the start and at the end, so we have a 1 here. So in the middle, what are we going to write? Well, we're going to add this 1 and 1. That gives 2, then we have a 1 at the end. Okay, so we go again. We have a 1 at the start, 1 plus 2 is 3, 2 plus 1 is 3. Then remember we have a 1 at the end. So we have a 1 at the start, 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Then we have a 1 at the end. So it just keeps on going like that. So we could do another one. So we have 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1, 5, and don't forget your 1 at the end. So you can see that it forms like a triangle. Alright, so I just want you to have this at the back of your mind. So let's take this down. Alright, so we can have space to solve. So how exactly are we going to use this Pascal's triangle to solve this question? Well, if you want to solve any question, the first thing you will look at is the number that we have here. What is it raised to the power of? It's raised to the power of 3. So which row are you going to take note of? Well, you're going to take note of this row. This row over here. Okay, this one over here. So how do I know which row? Well, you can do this in two ways. You can say this is the 0 position, this is the first, this is the second, and this is the third. And since this is raised to the power of 3, we stop at the third position. You can look at it is, remember this is 3, so wherever the second number is in alignment with the number it says you are looking for, then you would use that row. For example, this is 3, like I've mentioned, and the second number in our row here is 3. So if it was raised to the power of 5, we would take this row because the second number is 5. But at the same time, you could also do this first row is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So however it is that you remember it, you can do it like that. So we don't use all the rows. So in this case, we're going to use this particular row, 1, 3, 3, and 1. So this is how you're going to start. So we have 1 plus 2x, everything to the power of 3. So we have our first coefficient, this number here, which is 1. So we have 1. So what we're going to do is put this 1 into brackets, and we're going to raise it to the power of 3. Okay, then you put the 2x in brackets. You can write plus 2x if you want to, or you can just write 2x since it's already plus. We can just write 2x. So we have 2x raised to the power of 0. Okay, just take note of that, raised to the power of 0. So we have plus, you go to the next coefficient, which is 3. So that will be 3. You open the bracket, you put 1 inside again. Now remember this was 3, or this is 3 here, right? As we keep going, this would be decreasing by 1. So now this is 3, so we're going to have 2 here. Okay? Now since this is decreasing, it means that this one here is going to increase by 1. So this would be 2x raised to the power of 1 now. Okay? So could you guess the next one? Let's see, 3, because the next coefficient is 3. Okay, you make sure that you go back to look at your coefficients in your Pascal's triangle. So this is 3. Open this up. Oops. So we have this. So now this 2, remember this power here decreases, so it's going to go to 1. Then this one here increases, so we have 2x 2. Then we have our final, which is our final 1. So that will be 1. Okay, 1 into brackets. Now this 1 will decrease to the final number, which is 0. And this 2 would increase to the final number, which is 3. So that will be 2x to the power of 3. It's as simple as that. Okay, so what you're going to do now is simply open up the brackets. 1 to the power of 3 is 1. 1 multiplied by 1 is 1. 2x to the power of 0 is 1. So everything here is 1 basically. Okay? You can use your calculator if you need to. So 1 to the power of 2 is 1. 1 multiplied by 3 is 3. Alright, so we have 2x. So 3 multiplied by 2x would be 6x. Okay? So we have this. So 3 multiplied by 1 to the power of 1, this is 3. 2x squared. This would be 2 squared and x squared. So 2 squared is 4 and x squared is x squared. Okay, so this would be 4 multiplied by 3, so that would be 12. Now make sure you don't forget to write x squared. You can't just write x because remember this squared also covers this x. So now let's go to the final one. 1 multiplied by 1 to the power of 0, this is 1. Then 2x to the power of 3 will be 8x cubed. So 8x cubed multiplied by 1 will be 8x cubed. That's 8x to the power of 3. So another way I would like to check it, or one of the ways rather I'd like to check to see if my answer is correct, is I'll just put any random number here for x. So I'll put a small number so I can really cross-check my work very easily. So I could say x is equal to 2. So if I say x is equal to 2, and if I was to open up the brackets, that would be 2 multiplied by 2, which is 4. 4 plus 1 is 5. Then 5 to the power of 3 would give us 125. So remember, so we have this 125, so let's just keep this at the back of our head. And we got 125 when we made x equal to 2. So what I'll simply do is put 2 into wherever I see x, and if this equals 125, I know my answer is correct. If it does not equal 125, then my answer is wrong. Okay? So let's see. 2 can, so if we expand this using 2 as x, this would be 1 plus 6 multiplied by 2 will be 12. 2 to the power of 2 is 4. 4 multiplied by 12 is 48. 2 to the power of 3 is 8. 8 multiplied by 8 is 64. So if I add all of these, it should give me 125. So 1 plus 12 is 13. 13 plus 48 is 61. And 61 plus 64 is 125. So it means that this answer is correct. Okay, so let's do one more example using the Pascal's triangle method, and then we'll go over to using combination. So we have using binomial theorem expand 2 plus x, everything raised to the power of 5. So we want to use the Pascal triangle method. So we draw the Pascal's triangle. So we have 1, or let's take it lower. So we have, okay, we can leave it here. So we have 1. Then remember we have a 1 at the end, and 1 at the start and 1 at the end. Okay, so we have a 1. Then in between, we just add what is there. 1 plus 1 is 2. And we have a 1 at the end. Okay, so we have a 1 at the start. 1 plus 2 is 3. 2 plus 1 is 3. And we have a 1 at the end. Okay, so we have a 1 at the start. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we have a 1 at the end. So now you could ask, well, how exactly do I know when to stop? Well, you look at the number we have here. This is 5. Okay, so it means this is 0, 1, 2, 3, 4. So the next one is where we're going to stop. Like I said, another way you can look at it is look at the second number. The second number here is 1. Second number here is 2. Second number here is 3. Second number in this row here is 4. So it means that the next row would match whatever we are going to do here, because this has 5 as the power. Okay, so we have 1 here. 1 plus 4, we have 5. 4 plus 6, we have 10. 6 plus 4, we have 10. 4 plus 1, we have 5. And we have a 1 here. Okay, so it means the rest of these guys we don't need. We don't need the rest of these guys. So we can take them all out. So it's just these numbers that we need. 1, 5, 10, 10, 5, 1. Okay, so now let's solve. So we take our first coefficient, that's 1. Then don't forget to put your 2 in a bracket and raise it to the power of 5. That's the highest power over here. Then we have x. Okay, you raise that to the power of 0. It starts from the beginning. Okay, so we have plus. Then we go over to the next coefficient, which is 5. So we have 5. Your 2 inside a bracket. Now remember, it decreases, so this over here will be 4. Then x, the power would increase. So that would be 1. Plus, we look at the next coefficient, which is 10. So this would be 2 over here. Then this 4 would decrease to 3, and x would increase again to 2. Then we go over to the next one. So I think we can write this here, plus 10, 2. This would decrease to 2, and this x would increase to 3. Then we have just 2 more coefficients, so let's work with 5. So we have 5 plus 5. So we have our 2 here. So it's going to decrease to 1, and x is going to increase. The power of x is going to increase to 4. Then we have our final coefficient, which is 1. So we have 2 over here. Okay, have a coefficient, we have a power rather of 0, and x, we have a final power of 5. So we work this out and we would get our answer. So 2 to the power of 5, you can use your calculator for this, but 2 to the power of 5 will be 32. 32 multiplied by 1 is 32, and x to the power of 0 is 1. So we have 32 here. Plus 2 to the power of 4 would give us 16. 16 multiplied by 5 would be 80. And x to the power of 1 is x, so we have 80x. Okay, so we just expand the brackets. 2 to the power of 3 would be 8. 8 multiplied by 10 is 80. Then x to the power of 2 is x squared. So that would be plus 80x squared. Okay, 2 to the power of 2 is 4. 4 multiplied by 10 is 40. So x to the power of 3 would be x cubed. So that would be 40x cubed. 2 to the power of 1 is 2. 2 multiplied by 5 is 10. So that would be 10x. X to the power of 4. Then 2 to the power of 0 is 1. 1 multiplied by 1 is 1. Then 1 multiplied by x to the power of 5 would be x to the power of 5. So this is our answer. So if you want to check if it's correct, let's use same method. Like I said, so we can find out our answer easier. Let's use x as 1. So let's say x is equal to 1. So if x is equal to 1, that would be 2 plus 1, 3. Then 3 to the power of 5 would be 243. So it means that if we replace all these values of x with 1, it should give us 243. So let's try that. So this will be 32 plus, if we replace x with 1, that will be 80 times 1, that will be 80. If we replace x squared with 1, that will be 1 squared. 1 squared is 1, so that will still be 80. 1 to the power of 3 will be 1. 1 multiplied by 40 will be 40. 1 to the power of 4 is 1. 1 multiplied by 10 is 10. Then 1 to the power of 5 is still 1. So if we add all of these, it should give 243. So 32 plus 80 is 112. 80 plus 112 is 192. Plus 40, 232. Then plus 10, 242. Then plus 1, 243. So we see that it gives us this particular answer. So it means that this expansion is correct. Okay, so now let's go over to using combination, or how we can use combination methods to solve this. Okay, so let's go back to the first example that we've done. For the combination method, which is what we're about to do now, let's just go over combination. So if we have something like this, n combination r, the general formula for this would be n factorial over r factorial into n minus r everything factorial. Okay, meaning that if we have something like 4 combination 2, we would have 4 factorial over 2 factorial multiplied by 4 minus 2 factorial n minus r, 4 minus 2, which then would be 2 factorial. So if we're to multiply this out, 4 factorial simply means 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, then 2 factorial will just be 2 multiplied by 1. Same thing here, multiplied by 2 multiplied by 1. So 2 multiplied by 1 cancel each other out. So 2 would cancel 4, would have 2. So 2 multiplied by 3 would be 6. Therefore 4 combination 2 is 6. So now that we have that out of the way, we have 1 plus 2x everything to the power of 3. So what you're going to do is you're going to start with 3 combination 0. Okay, then you're going to take your 1. It's very similar to the one before. Take your 1. This would be raised to the power of 3. That's the 1 over here. Then take your 2x. And this would be raised to the power of 0. Okay? Then after 3 combination 0, we go to 3 combination 1. Then you take your 1. Then remember the power of the first value that we have in the bracket would decrease. The power would decrease. So this is 3, so over here it becomes 2. And this increases, the power of this one increases. So this is 2x to the power of 1 plus 3 combination 2. This one would be to the power of, remember, 2, so it decreases to the power of 1. Then we have 2x to the power of 2. Okay, now we know that we are going to stop at 3 combination 3 because there is nothing like 3 combination 4. Like if you type that in your calculator, let's try that, 3 combination 4, you would get math error. Okay, if there's not like 3 combination 4, so we'll stop at the final, which is 3 combination 3. So this is our final one, 3 combination 3. So we have our 1. The power here is 1, so it will decrease and it will go to 0. Then we have 2x. The power here is 2, so it means it will go to 3. Alright, so if you have a calculator, it will be very easy for you to solve this. Okay, if you don't know it, you can just solve it the manual way. So 3 combination 0 would be 3 factorial over 0 factorial 3 factorial. Okay, there's no need to calculate anything. 3 factorial times 3 factorial, so that will be 1. Alright, so 3 combination 0 is 1. 1 multiplied by 1 to the power of 3 is 1. And 2x to the power of 0 is 1. So we have 1. Okay, so 3 combination 1. 3 combination 1 would be 3. 3 multiplied by 1 squared is still 3. Then 3 multiplied by 2x is 6x. Okay, so we have 6x. Then 3 combination 2. 3 combination 2 is 3. 3 multiplied by 2x squared. Well, 2 squared is 4. 4 multiplied by 3 is 12. So that will be 12x squared. So we have plus 12x squared. Okay. Then we have final one, which is 3 combination 3. So 3 combination 3 is 1. 1 multiplied by 1 to the power of 0 would be 1. Then 2x cubed. 2 to the power of 3 is 8. So this would be 8x cubed multiplied by 1. So this here will be 8x to the power of 3. It's as simple as that. So like I said before, if you want to check if your answer is correct, you can just rewind the video to see. You can rewind the video to see if it's the same thing, because we did this example before. Whether you use the Pascal triangle or the combination method, it should still give you the same answer. Okay, but like I said, you can replace x with whatever value that you want to, and whatever answer you get here, if you replace x with that same value, you should get the exact same answer. Like I said, if you don't have a calculator, right, you can solve this the manual way. If you do 3 combination 1, that would simply be 3 factorial divided by 1 factorial multiplied by 3 minus 1. 3 minus 1 is 2, so 2 factorial. Okay, and that would give you 3 multiplied by 2. Whenever you say something factorial, so if you say 5 factorial, if you say 5 factorial, this simply means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So it's like you're multiplying the value backwards. Okay, you're multiplying consecutively backwards. So that's what this is. So 3 multiplied by 2 multiplied by 1. The 1 factorial is simply 1 multiplied by 1 or whatever. Then this here would be 2 multiplied by 1. Okay, so 2 multiplied by 1 cancels 2 multiplied by 1, so we have 3 left. So that's why 3 combination 1 is 3. So that's just a way that you can solve it. So you can either solve it using Pascal's triangle or combination method, whichever method is fine for you. We could have questions like this as well. Determine the coefficient of the 4th term in 2x minus 3y, everything raised to the power of 6. So there are two ways in which we can do this. So the first way is to use a formula. We can use a formula and easily get the fourth term, okay? And we can use the normal method, whether it will be the Pascal triangle method, then count the fourth term in that, then just pick out the coefficient, or the combination method where we would pick out the fourth term and the coefficient of that as well, okay? So obviously the formula method would be the easiest because you don't have to solve for everything. You can just solve for the fourth term, then get the coefficient, all right? But in case you don't remember the formula, I will explain using the binomial, the normal method, the Pascal. Let's use the Pascal triangle. Then afterwards, I will show you the formula with the same question. Okay, so determine the coefficient of the fourth term in this. So let's draw the Pascal's triangle. So we have 1, and we have 1, 1. Then we'd have 1. 1 plus 1 is 2. We'd have another 1 here. Remember, we're trying to get to 6. So we want our second term to be 6. Then we can stop drawing the triangle. So 1, 2 plus 1, 3, 2 plus 1, 3. Then we have a 1. So we have 1, 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4, and we have a 1. Four plus 1, 5, then we have 1. So now the second number here is 5. We need to get to 6, so we have one more. So 1, 5 plus 1 is 6. Voila, we've gotten here. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Then we have a 1. So this is all we need. 1, 6, 15, 20, 15, 6, and 1. Okay, so let's pick this. Let's take this up. So this is all we need. Then we don't need the rest. So let's take it out. So these are the coefficients that we need. So let's start to solve. So we have our first coefficient as 1. Then we're going to have 2x. 2x raised to the power of 6. Okay, then minus 3y, because the minus 3y raised to the power of 0. Okay, then we have plus, take the second coefficient, which is 6. Then we have 2x. The power will decrease by 1, so it turns to 5. Then negative 3y, the power will increase by 1, so minus 3y raised to the power of 1. Then we go to the next coefficient, which is 15. So that will be 2x to the power of 4 this time, and minus 3y to the power of 2. Okay, then we go to the next, which is 20. 2x to the power of 4 would go to 3. Minus 3y would go to 3 as well. Then we have 15. 2x would go to 2. Minus 3y would increase by 1, and it would go to 4. Let's write this properly. Okay. Then we have 6. 6, 2x. This would go to 1, and minus 3y would go to 5. Then we have one more. Let's take this a bit downwards so we can have that there. And we have our final coefficient, which is 1. So that will be 2x to the power of 0, then negative 3y to the power of 6. So we're done with this. So now we don't need to solve for every single thing. There is no need to do that. Alright, all we need to do is count the fourth term. 1, 2, 3, 4. This is our fourth term over here. So that would be, so when we expand this, let's expand it and see what we get. So we have 20. 2x to the power of 3 would be 8x cubed. Minus 3y to the power of 3 would be 3 to the power of 3 would be 27. So that would be negative 27y cubed. Okay, so now let's open all of this up. So 20 multiplied by 8 would give us 160. If we multiply that by negative 27, we have minus 4,320 x cubed y cubed. But the question said determine the coefficient of the fourth term. So since this is the fourth term, this is simply our coefficient. So we can write the coefficient of the fourth term is minus 4,320. So I want you to maybe write this down, because we're going to use the formula method now. So you can write this down, keep this in your head, however the case. So let's use the formula method and see if it gives us the same thing. So let's write down the formula really quickly to find the nth term in the binomial expression. So if we want to find the fourth term, this would be the formula. So we would have n combination r into, so we have n minus r to the power of r. So let's just define the terms really quickly. So what's our n? Our n is going to be 6. All right, whatever your question is raised to the power of, so if it's raised to the power of 5, your n will be 5. Then what's your r? The question says we should find the fourth term, but your r is not going to be 4. Your r is going to be 4 minus 1. So your r is going to be 3. Okay, so if the question said find the second term, for example, your r is going to be 2 minus 1. All right, whatever term you want to find, just subtract that by 1. Then your a is simply 2x, and your b is simply minus 3y. As simple as that. So let's just put all of this into the equation and see what we have. So this would be 6 combination. Remember, we're not writing 4. 4 minus 1 would be 3 into brackets. Then what's our a? Our a is 2x raised to the power of n minus r. So that would be 6 minus not 4. Remember, your r is 3. So that would be 6 minus 3. Then what's your b? Minus 3y. Then your r is 3. So by the time you open all of this up, it should give you the same thing. So let's see. If you solve for 6 combination 3, you would get 20. So 20 multiplied by 2x, this would be 8x cubed, multiplied by, this would be minus 27y to the power of 3. So we just multiply the coefficient and that would be our answer. So 20 multiplied by 8 is 160, multiplied by negative 27, and that would be minus 4,320. So you could just rewind to check back and see if it's the same thing. But if you remember correctly, then this is our answer. So obviously this method is way easier. You can just have this formula in your head, and solving these kind of questions would be extremely simple.